In today's lecture, we will continue discussion on service-oriented architecture. So we will focus on the third part of service-oriented architecture, that is portals and science gateways. So before going to these portals and science gateways, like if you go to the portals and science gateways, you will see there are numerous for numerous scientific and engineering applications. There are a lot of real-life portals and science gateways are available. Like you can say for the chemistry project, one specific gateway is available for ultrascan. There is another software that is called ultrascan. Therefore, some this gateway is available for few applications. So before going to that one, let us discuss the fundamental parts of the portals and gateways. And after that, one you will comfortable in this portal and science gateways. Then I will give you some real life examples with respect to these portals and science gateways, so that you will understand that how these portals and science gateways are helpful whenever we are going for a scientific or engineering applications. So whenever we are discussing about portals, you know that whenever we call this particular word, then you can say that there are a lot of portals are there, like Government of India. The Government of India also has several portals are there, right? And like education portal is there, for agriculture portal is there, right? Or if you see, suppose you want to do a particular transaction, right? Suppose I want to book a train ticket, right? If you want to book a train ticket, then what happens? You are opening the IRCTC website. Okay, so you are invoking a web browser, right? You are accessing a web browser. You are typing a particular URL. Then IRCTC website is will open. Then you are writing your credentials like username and password. Once you fill up the username and password, you are selecting a particular option. You are giving your requirement, right? Once you give your particular requirement, what happens? Then it is asking for the payment option, right? So what you are doing, you are switching from IRCTC website to a payment gateway. Okay, that is nothing but bank, right? Again, when the payment is successfully done, what you are doing, you are again back to your original website, right? Where you have proceed to the payment gateway, right? So this is the process we are doing, right? So you know, whenever we are doing such payments, what we are doing, we are moving from one website to another website, right? So for this, what you need? You need a gateway, like you know CC Avenue, right? CC Avenue is there, right? Whenever you are paying some amount, so this gateway helps us to move from one website to the banking website and redirect the banking website to the original website. Okay. So these things will help us to understand the portals and science gateways. But whatever things I will discuss today, that is more or less that is the applications where the science and gateways plays a major role. Okay, science and gateways are used. So these words may be new to you. The words whatever I use in today's lecture, they may be a complete new to you. But these are the portals and science gateways that are used in our scientific and engineering applications, right? So these portals or science gateways may be available in the form of a toolkit. Like I told you in some class about the cloud analyst, and I also told you can download the cloud sim. It is an open source software, and it is simulation, not experimentation, simulation. Right? It is giving you a virtualized environment. In that virtualized environment, you can deploy your application, or you can schedule some applications, or you can assign the task to the resources so that they can execute in a particular resources, and you can calculate the waiting time and the completion time, execution time, these things you can do, right? So whenever we are talking about these portals and science gateways, it may be also available in the form of a tool, right? Like cloud SIM tool also, we are moving from one company to another company. Like you want to send your data from region 0, in region 0 you have a user base, and region 0 decided to execute the work in the region number 3, right? Okay, and region number 3 is having your data center, right? So what we are doing, you are moving from one region to another region, for which you need require some gateway, right? So for collaborations also, suppose you want to collaborate with one company, wants to collaborate with another company, so they want to use a common portal, right? Like TCS or Infosys and you go for Microsoft like that. So whenever they are developing a software, so if you go for a particular location like Hyderabad, let's say Hyderabad, all the things are not performed in the Hyderabad location. For example, one location is responsible for the requirement analysis. Another location may be dedicated to design. Another location may be dedicated to testing. Another one may be restricted to your let's say maintenance, right? So like that, you can see you can collaborate various branches of the Infosys and Microsoft or any MNCs. They can collaborate in order to build a particular project, right? There these things will come into picture. This portals and science gateways are picture, right? So providing a user-centric environment for interacting with remote computational resources, right? So your resources are available and resources are headed by a particular gateway, right? So whenever you put your requirement, the gateway is going to assign a computational resources to you in order to execute your work. Okay. Invoking a user interface, and this user interface is connecting to the gateway. Like a website is whenever you are paying some amount in IRCTC website, you are paying in a there is a web page, but it is changing from one side to another side, right? So that is called as a gateway, right? So sometimes gateway is also called as websites, right? Because this movement from one website to another website is reflected in the form of a in the web browser only. So you can say it is also similar, a lot of similarities with websites. And if you see some of the practical examples of the gateway, like Hop Zero is one of the gateway, okay, that is providing the solutions of the gateways, that is your turnkey solution or toolbox solution, which is executed by your open gateway computing environment projects. So these are the gateways and the solutions to the gateway software. So they are providing you end-to-end solutions, and they are also providing you the infrastructure to host your application, and also provides you the features to select a particular computational resources in order to execute your application. So this is a typical picture. You can see there is a API portal is there. So this portal is managed by a company admin people, right? They are managing anything, and based upon the feedback received from the customer, based on the comments received by various stakeholders of a particular organizations, they are going for an interactive, you can say graphical user interface, GUI based portal they are making, right? And if anybody want to use that particular portal, right? If I want to use this particular portal, what I have to do? I have to register with this particular portal. Right? Like in a particular website, if you want to access their documentations, access their products, access their various implementations, what you want to do, you have to simply register. Right. So once you register with a particular portal, so what you can do, you can develop the applications. You can create a particular application, and you can manage that application. You can modify that application. You can generate the various version of that particular applications. That is done by the developer peoples, right? And these developer peoples, what they are doing, they are developing various applications. Okay, or they are modifying the current application with a new application with some added features, right? So sometimes what happens, these applications switch from one website to another website, or one component to another component, for which we need to connect with a API gateway, right? And you know this gateway is need to be more secure, right? Whenever the payment is concerned, if you are looking gateway in the payment perspective, so you have to ensure that the proper security mechanism should be enforced to the gateway, so that any intruder or any person who is not authorized to see the information, they should not reveal the information, or they should not monitor your actions, or they should not modify actions, right? That's why you need some security mechanism in order to make the entire system safe, right? Another reason of going for these portals and science gateways, like one of the example you can see, like in computer science we are using one of the best example, that is called as GitHub, right? What happened, this is a forum, right? This is a forum where you can post your codes, or you can take the codes of others and can design, can modify the code, can develop a new code which is better than the previous code, and again share the code with the GitHub, right? So that if you get enough number of hits, okay, or enough popularity, then what happens, the people who want to assess the same problem code, then they can use your code to uh, determine a particular solution, right? So that way also this portal will play an important role. If a common portal is given to all, right? So what will happen? Everybody will rely on that portal, so that for any specific problem there may be a solution available in that particular portal. Okay, so I told you these things are nothing but, if you go for development part, this is also called as a toolbox, right? And toolbox are designed for a specific problem, like cloud sync is available. You know that there is an improvement over the cloud computing, because cloud computing is facing a lot of latency, that is delay, because the servers are present far away from the user perspective. So what happened? The delay is more. So in order to avoid this delay, people are now interested in the fog computing, right? So in fog computing, if you go, user are getting solution very faster in comparison to the cloud, right? Fog is an intermediate layer, you can say, in between the user and cloud. So if you go for that one, people have developed a new toolbox for fog, that is called as fog sync, right? Earlier for the cloud they have developed cloud sync, but later they have modified the same software and make it compatible with same runtime environment, and they launched a new name, that is called as fog sync, right? So for a particular specific problem, right? Like here the problem is the latency, okay, which is delay. And in order to address the delay, or in order to reduce the delay, a lot of computations need to be solved in the user end without moving to the cloud end, right? And this customization, everything for that we are designing a particular toolbox. A lot of toolbox are there with respect to the subject. Like in software engineering, there are a lot of toolbox are there for designing various softwares, right? Or in any research topic also, if you pick with respect to the research topic, some toolbox are there, which is going to be help us to find a particular solution for a specific problem. Like though now nowadays people are working in neural network, right? In neural network also, if you go to MATLAB, you can find there is a predefined toolbox is also there, right? In the neural network. So you need not implement the algorithms in the ground level, right? Rather than you can use these application, these you can say commands, right? Simply like standard deviation, if you want to find the standard deviation, already there is a function SD, let's say a function SD. So no need to write the code for the standard deviation, rather than you can use SD, right? Similarly, Python also, you know that there are a lot of packages are available. These packages enable us to do the codings with less number of lines, right? Similarly, there are a lot of toolbox are designed for scientific and engineering applications. So if you see the gateways architecture, so I will show you the gateway architecture. It is divided into four different tiers. So this is a gateway, and you can say gateway component software stack for scientific applications. So you can see there are four layers. You can see this is called as the bottom layer, that is tier 1, tier 2, tier 3, and tier 4. I told you generally in cloud perspective architecture, any architecture you pick, the bottom level is always the hardware layer. Like we have also seen in the OSI reference model. Also, we have seen in the case of TCP/IP model, bottom layer is always dedicated to our hardware, and top layer is always responsible for is close to the user, right? That user interfaces, desktop computer, or you can say any kind of interfaces, APIs will come in the top layer. So what is the responsibility in that tier 1? You can see tier 1 is responsible for the computational resources. So there are two type of resources are there. One is compute intensive and another is communication intensive. In computation intensive, you are giving more emphasis to how faster you are executing the instruction. But communication intensive tasks are what happen? They spend more time in the communications. Once you are getting the result in a particular problem, that problem need to be given input to another program, right? And the transmission time between two different unit is more. That's why it is called as communication intensive task, right? So these computational resources, you can see here, they are calling it a computational cloud. So where it is relying on how faster you can execute. If a application is given to you, and how efficiently or how faster or you have to execute the application with minimum completion time. Okay. For that, computational cloud and computational creates local resources, or as I mentioned, BOINC platform, they are collecting resources. Similar resources you have to collect to execute the work. Okay, so that is the first layer, that is the bottommost layer, which is called the resource layer. So here, one of the popular grid resources you can say, that is a TeraGrid. Like BOINC is a platform, TeraGrid is another platform which takes around 11 projects, right, and providing resources to these 11 projects, right. Similarly, if you come to the tier 2 is called as a middleware, right, in middleware layer. So in the middleware layer, in grid computing, a lot of middleware is there. One of the popular middleware you can see that is called as a Globus. Okay, that is Globus toolkit is available. GT4, GT5, 5% is also advanced to long vector. So these middlewares are also available in the tier 2. So what is the role of this middleware? This middleware is interacting with the request, right? Whenever you are seeking some request, if your request is reached to the middleware, and middleware is going to select a particular resources or a set of resources for you, right? For your application. Whenever you want to deploy a particular application, some resources need to be allocated, right? So in order to run your application or in order to manage your application, you will need some resources, right? That Globus is going to provide. That's why Globus is executing the client's job. Okay, it is executing the client's job, and it is also responsible for remote file management, right? That is monitoring the status of each and every jobs, and monitoring the files that are in the remotely. Similarly, another popular you can say middleware, that is called as Panda. This Panda is used for providing the job security, right? Which job need to map to which resources, that is the possibility of Panda, right? Very famous one. Third one is your iRods. iRods is dealing with the data and the metadata management and data management. So these middlewares helps us to map the user applications or user request with the resources. That is the role of the resource middleware, which is tier 2. And tier 3 is providing various features, like if a resource is failed, fault tolerance mechanisms are there. This fault tolerance mechanism ensure that even if a fault is there in the system, you will get your output in the desired time. Okay. or as per the schedule, you are going to get result, right? So this fault tolerance mechanism, or you can say, actually, I told you the X registry previously. So the detailed information about the services is available in the registry. Auditing and reporting, whenever you are submitting a request, right? So there are details when it is scheduled, and which resources it is executing, what is the utilization of that resources, okay, and detailed about the life period of the request, everything will be maintained in the form of the report, right? That is the responsibility of the auditing and reporting unit, and you have to ensure that the resource is being properly used, right? So that is coming under the tier number 3, which is called as a gateway software. So tier 3 relies on your tier 1 as well as tier 2 to manage the execution of the scientific application. Apart from this, you can see tier 3 is also responsible for initial invocation of a, invocation means invocation of a services, and monitor the status of each and every service, whether the service is running or whether the service is requiring some kind of high operation or whether the service needs more resources, everything is monitored. It is also responsible for fault tolerance. It is also responsible for the task occurring as workflows. So these tasks are generally dependent in the form of the workflows. I will tell you about the workflows shortly. The workflows is nothing but I repeatedly told you that workflows that are directly acyclic graph, where there is a dependency among the various tasks are there. So based upon the dependency or the precedence constraints, you have to execute the task, right? So that is the responsibility of gateway. Like if you in the social networking websites, you can go for Facebook or WhatsApp, what we are doing. In these, we are creating various groups, right? This group management and communicating the members with the members of the group is the responsibility of the tier number 3. Tier 4 is responsible is close to the user, so it is called as a user presentation layer or simply called as the presentation layer. So here what happened? How user is going to assess the gateway, right? How we are assessing the payment gateway? Through our user interface, or through a computer system, or through a gadget, or through a handheld devices. So any devices which is connected to the internet can be used in the tier 4 to access the gateway, right? And if you see the example of two examples of the scientific gateways, okay, which is used in the scientific research, that is called as GridChem. GridChem is related to the chemistry project, and the ultrascan is used by biologists, physicists, material science people. They are using the second science gateways. Okay, so this is the complete software stacks of the gateways, which is divided into 4 different layers. And in order to illustrate the gateway concept, so there are 3 examples we will see. That's I introduced in the previous slide. First one is your grade chem, that is also called as your computational chemistry grade, that is CCG. Second one is called as your ultrascale biophysics gateway, which is used by the physicists and biologists. And the third one is your nano hop technology gateway. So these 3 are the real gateways. Okay, science gateways. So one by one I will discuss. So you can get more details in their website. If you visit their website, you will get more details. But in abstract level, I will tell you, although these are not related to directly to the computer science, right? Only as the resources are available, resources are there. We are mapping these projects with our computer science, but the computations that are there, that is belongs to other domains, right? Like chemistry, physics, and biology, and materials, and something like that. But as computer resources are used, we are keeping these as a part of our science lectures important, right? Otherwise, these projects, whatever details are there, you may not understand the details about these projects, right? The first project uses TerraGrid. I told you, like BOLC platform, TerraGrid is another platform in order to provide the resources. And it also provides you a great enabled desktop interface by which you can set up and launch and manage computational chemistry simulations. Like you have also seen that in physics lab and chemistry lab, you did so many experimentations. So there are some experimentations are there in chemistry, which is practically not possible with a limited resources. Right, within 2-3 computer systems or within 10 computer systems, it is not practically possible. So as there is a need of massive computational resources, you have to rely on grid or cloud, right? Like here, if they are saying if such applications are required, you can go for terabit, right? And it also this grid can it also supports your Gaussian and the car and games. These are the applications supported by grid can. So here the computational demanding application, these particular gateway, if you see, they require the resources like a supercomputer. Right? The computational requirement of these projects, if you see, the requirement can be fulfilled by a supercomputer, right? In supercomputer powers is required, or you can go for distributed computing in order to achieve the same power in order to run such applications. So what happened in this project? Several researchers are associated with these projects, so they want to use the computational resources. They can form one group also, like user and group will see. So they can form a group, they can discuss the things, they can share the results. Okay. So if some shared location is there, like one data set is available. Let us assume that for this particular project, one data set is available. So the data set should be accessible by all the researchers, so that they can compute the things by the help of that particular data set. So these data sets should be available to all the users. So it should be available in a shared location, so that each and every user can access it. Second is ultra-scan biophysics gateway. This is used by, I told you, biochemists, biophysicists, and material scientists are doing. Again, they want to solve some flow equations. Okay, they want to find some solutions. Okay, finite element solution of flow equation, right? So for this, if you see, also machine computation resources are there. So these projects are also dealing with design various drugs for cancer, for HIV, AIDS, diabetes, okay, various diseases and aging. So this software is providing such type of data sets as well as such type of solution to these data sets. So one report says that these ultra-scale softwares are used by 700 plus biophysicists, biologists, and material scientists from all over the world. And they have also published quite a good number of research papers. Like they reported that 250 plus research papers are published based upon the ultra-scale gateway. And out of these publications, 250 publications, 23 publications are available from 2009 in terms of their citation index, how many people are referring these articles. Based upon that, you can say these 23 are very known and well-known publications using this ultra-scale software. Okay, yes, the software must run on the cluster and supercomputer, right? Or you have to get a group of computers in order to run the ultrasound, like BYNC platform, right? In BYNC platform, lot of people are contributing their computational resources, and also the data sets with respect to around 40 to 50 scientific applications are available in BYNC. So what we are doing, we are running these applications on the resources of the users, right? Or you can use, if you have a cluster or supercomputer, also it is very easy for you to do it, right? So this ultra-scale job management service is available in the tier 3 of the science gateways, where fault tolerance is coming and auditing and reporting is coming, right? So what they are doing in this ultra-scale, it is also providing a optimal solution for a non-negative least square problem. It is a very popular problem you can search. The problem is that you are given with a matrix A, right, of any order, and a column vector is given of response variable y, your goal is to find ARG of mu x of equilibrium norm of ax minus y subjected to x greater than 0. So if you want to solve this non-negative least square problem, it is not possible to do the same thing with limited resources. Means in your computer system, you see finding the solution is very difficult, right? So what you need the computational resources. So this ultra scale software is providing that software by the help of the processor and the supercomputer, so that people can solve this non-negative least square problems. Or if you have designed a particular solution, which is by the help of the parallel programming, right? So that in a lesser time you can execute you can solve this non-negative least square problem. So in that angle, this ultra scale software can help you, right? And ultra scale, yes, it is mentioned that solving requires significant number of computational resources. That's why this it may also require more resources, more computational resources. And here also they are these researchers are also interested for analytical ultrasynthesis, which is used by the biophysics to characterize the macromolecule and neutralize the molecular weight and cell. Right? They are dealing with this ultrasonic software to find the various features of the macromolecule and molecular weight and cell. Right? For this also the computational resources is more, because the data size, if you see, it is increasing in an order of 3. Okay, so our data size is not small. The data size is increased by order of 3. So also in order to deal with this multi-wavelength data, you require enormous computational resources like cluster and supercomputer. So there also ultrasonic plays an important role. The next one is the third one, that is called as nanohop.org. It is also a gateway and it is available in many forms. Right? I'll tell you, there are 3 forms it is available. So, okay, it is operated by our NSF, National Science Foundation, funded network for computational nanotechnology to support national nanotechnology initiative in the United States. So initially there are 1,000 users are using this particular gateway. Out of these 1,000 users, mostly people are belong to the Purdue University. But at a later point of time, 290,000 visitors are using this gateway per year, right? From 172 countries. And many people are launching various applications, like one specific date also mentioned here, like August 2019 to July 2010. In 1 year, 8,600 users assessed more than 170 nanotechnology simulation tools and launched 3,40,000 simulation runs. So this same is our GitHub. GitHub also, you can see many users are accessing to the GitHub, right, in order to write the program or in order to assess the program and in order to share their updated code, like that, right? Similarly, this platform is a very popular platform in the nanotechnology perspective. Okay, and these resources are free, like VOILC also, that is a voluntary services. People are using, giving their resources voluntarily, and their resources are used. And this Hub Zero is a open source platform from the Purdue University we have discussed. So it is going to provide various features. The first feature is compared with our YouTube.com. In YouTube, what happened? We are uploading videos, audios, right? And we are publishing our audios and videos. We can publish it publicly, or we can unpublish it, or we can restrict it to a particular list. Right? Suppose now I am uploading the videos and I am giving you the link, so that whoever is having that link, they can only access to my videos. Other people cannot access to my video. So in that angle, if you see whatever features YouTube is providing, Hub0 is also providing, Hub0.org is also providing the same features. If you compare the features with Google Groups, in Google Groups you are doing, you are getting a private space, where you can share your documents, send messages among the group members. So Hop0 is also providing such features, whatever features is there in the Google page. And also Amazon.com having a Ask Willy. Okay. So the purpose of this one is to ask the questions and post responses, right? Somebody is asking questions, just like our Quora, right? We are using Quora. Somebody want to assess which NIT is best, or how much, what is the minimum CGPA to get a job in Microsoft or something like that. We are posting the questions, right? So whatever any group member can post the answer, or admin can only post the answer. So such features are also available in the Hub0. And Hub0 is also providing you the services like source for Dept, where you can work the features like collaboration of the work and leaving your source code. You can share your source code with your community people. Whatever things available in the source code that also provided in the Hub0. So one of the advantages you can see the features what are provided by various websites like YouTube, Google, Amazon, SourceForge. Combinedly, these features are provided by your Hub0. Okay, this Hub0 platform is transparent to user. It is also providing a friendly graphical user interface so that you can use, and it is having a rapture toolkit. Okay, this Hub0 is having a rapture toolkit, and so you in the form of a diagram. So this toolkit enables the researcher to compare their simulation results. Suppose one person has developed one particular code, I have developed another code. How to know that which code is efficient? So in that case, what happens? We are comparing our result with others' result. Similarly, what we are doing, whenever we are carrying out a scientific engineering problem, we are not accepting the result what we are getting in a single simulation, right? So like machine learning also, those who are working in the machine learning, they know whenever they are running their data sets, whatever result they are getting, that result will be acceptable. So what they are doing, they are running the same simulation for multiple times. Let I am running the simulation for 100 times. After running 100 times, I got 100 result. Then I am taking the average of that result and I am saying this is my final result. And we ran the simulation for 100 times in order to get the particular result. It also providing the what if questions. Okay, it is this lecture toolkit is also provide you what if questions also you can do. So in Hub0, it is available in three forms. One is our global hub.org, which is having 29,000 active users. So this is the purpose of dividing into multiple examples is that the type of application is different, right? So here what happened, the students can work together and they can discuss about their projects like your 7th semester and 8th semester projects. What you are doing in a group, right? 3-4 people are doing the same project, right? So they are contributing to your work. So a similar type of projects, if you want to adapt or if you want to discuss with your group member or if you want to contribute something, so you can go for globalhub.org. Similarly, with respect to the medical application, there is a especially the cancer care application. So there is a another discussion forum that is called cchub.org. It is a gateway, right? Where the blood samples are collected from various patients, cancer patients, and by looking into the patients, some analysis is done by the help of mining techniques or machine learning techniques, or what are the possible treatment for cancers. So for that, they are collecting the data and they are developing various solutions. Another form of your hub.org that is called nees.org, which is dealing with the earthquake engineering simulations, right? So here you can see 14 institutions that are simulating the earthquake conditions in the earth. So they are collaboratively solving the problem, earthquake, how to deal with earthquake, how we know that it is a particular position prior to happening such events. So that how we analyze, right? For that we are using any.org. So this Hub0 architecture, if you see, so Hub0 Gateway is a website. In that website, if you visit, they are using a open source LAMP architecture. So you can see this is the complete picture. So this hop.org is using the LAMP architecture, where you have a operating system, Linux operating system, and Apache web server, and MySQL database to store the data, and your PHP web scripting. Right? This architecture is having four components: your operating system, Apache web server, MySQL database, and RSP web scripting. And I also told you Hop0 is having a Rapture toolkit, which is used to create graphical user interface. If already whatever things you have developed is supporting GUI, so within an hour you can launch your application in this Hop0 architecture, right? So there is a launch button in this architecture. You can see there is a launch button, right? I hope here is the launch button. If you click the launch button, what will happen? The middleware allocates a session container, like you are creating virtual machine on top of the physical machine. Similar kind of a container is allocated to you, okay, which is having X11 Windows system, which starts the tools and connect the session back to the user's web browser via a virtual network computing. So it is connecting your request with a resource, right? And these sessions, whatever session you have created, the session you can share with your group members, or you can close the browser, you can revisit the cloud browser as you can require. So you can see in the bottom level what we are using. Either we are using open source grid or TerraGrid. Okay, this TerraGrid is going to provide you the computational resources, or this open science grid is going to provide you the resources, right? And these resources are monitored by this middleware. Okay, middleware decides what should be the execution order. Okay, so that is determined by the middleware. So you can install this Rapture toolkit of Hop0 and export the things. Yes, I told you already that you can zoom a particular graph whenever you are designing a particular. You want to know the molecular weight and the space, or you want to go for a data analysis with respect to a cancer patient, or if you want to go for some medical application like HIV/AIDS and these things, right? Or diabetes, or aging, or something like that. You can get the visualization part in the number of technology, right? So you can zoom the things, right? If a graph is there, you can zoom the graph, or you can get the 3D image of the particular graph for data analysis. So that things are possible by the help of this Hop0 architecture. So if you have if you know about DC++, I told you in some class. DC++ is generally installed in a hostel environment, where what happens, you can share some videos and audios with your friends. So in order to participate in DC++, you have to fill the minimum quota. The minimum quota is that you have to share the 10 GB of data, then only you can able to view the data of others, or whatever say by others, that you can download this only if you are sharing your 10 GB of audios or videos or document or software, something like this. So each and every member has restricted with this quota. So once they fulfill the quota, then only they can use the resources, right? And you can see this tool says already, if you are designing a particular tool which is having the GUI, then within a matter of 1 hour, okay, or within hours, essentially 2 hours or 3 hours, something like that, you can deploy your application in your architecture. So it is also supporting tool developers can use the Hop0 toolkit, which supports the libraries of C, C++, Python language, MATLAB, Java, Python, Perl. These languages are also supported by this toolkit. Some other features you can see the list whenever you are whenever you are dealing with a new system, what happens? It is obvious that you are going to get some kind of error or some kind of problem, right? So what you have to do when you identify such issues, okay, regarding the bugs and error, so we want to we wish to report such error. For that, there is a support system is available. Like in each and every website, there is a support or there is a contact button, right? So here that there you will get the information. So by using that information, you can reach to a particular person, right? And sometimes what happens, the admin cannot answer all types of questions. Whenever we are building a particular software or a particular gateway or portal, so all the questions may not be answered by a engineer, the admin. So admin can give the privilege to some other user, or admin can give the privileges to other people to answer. And admin can later approve or disapprove based upon the answer given by other members, right? So that you can get the results in a better way. Or you can do ratings also. Once a answer is posted, what you can do, you can rate whether the answer is correct or not, right? Like academic also, you need to go for academic case. In the research paper case, we are dealing with the citation. The paper with the maximum citation, we assume that the paper is written very well and paper has nicely represented a new idea. Okay, uh, that academic citation, okay, in the academic literature gives the value to an academic article. Or you can rank the resources from 0 to 10 also. Yes, sometimes we are going for content tagging, right? Like YouTube also, I told you in the last class, suppose I want to upload a video, I am giving a particular name. Right? Nowadays, people are what they are doing, they are writing hashtag something, right? So, suppose I want to search with respect to that hashtag, then I will get more information about that. So, such type of tagging of the resources is also possible by the help of these platforms. And this user support area, I also told you that you are filling a particular form to get the support, and you are getting the answer, okay, from any registered user. That's why it is saying some questions are beyond the understanding of the staff. All the questions cannot understand by the admin, right? This is maybe there will be a language issue, there may be a technical issue, there may be different implementation issues, right? What happen? Any registered user can post the answer, and if that is sensitive information, then you can say that admin can approve it or admin can disapprove it. So based upon that, many platforms also giving PSATs to their participants. Suppose you have answered the maximum questions, then they will give some reward to you, right? So that respect to you will feel encouraged to post your answers in that particular platform. One of the popular websites, I don't know whether you know or not, that is Beyond Teaching. You may visit Beyond Teaching. Okay, in that website, there's several tasks. Once you did that particular task, they are giving t-shirts and mocks, okay, mocks or many gifts, small gifts to the participants. Okay, wikis and blogs are also available with respect to the science and gateways. Each hub is supported to create a topic pages. You can create your own page, and each and every page is written by a particular author. Okay, so once you make this web page public, like Wikipedia, suppose you are reading a particular article, you want to modify that article because you found that there may be some anomaly or there may be some mistakes by the original author. What you can do, you can report that thing to the original admin, or you can add that thing if the admin feels that that is a correct one, they can do it so that the information can be updated, right? Also, these such platforms are giving the user metrics. The user metrics, but how many users are online, how many UAVs are there. Like whenever we are visiting a particular website, you can see in the bottom part, it is showing what is the count value, how many users have visited to this particular website. Right? Such information we are getting, right? And we are also getting in which country people are interested in a particular website, right? With respect to the country also, you can analyze what is the vehicles. So that is the use of business metrics. And future direction is that suppose a pill resolution profile, you can see how the pill is working in the present system or in our body, right? Whether it is fulfilling the requirement or not. So such type of analysis can also be possible by the help of this Observer platform. For this, there is a specific platform that is called as pharmahub.org. So this platform helps us to deal with the field resolution profile. Okay, so if you have any doubt, you can ask now. Otherwise, I'll continue with the OGCE. Okay, in another 10 minutes, you can continue. So OGCE stands for your Open Gateway Computing Environment, like we discussed about UltraScan, GridCam, right? Then we discussed about a lot of details about the object. Similarly, there is another gateway computing environment, that is OGCE. So this OGCE project is a provider of our open source gateway software. Okay, that tool, if you see, consists of the following components. One is called a OGC gadget container. So it is a open tool for integrating the user interface component. It is having a X registry, which is storing the registry information. Another is Xbuyer, which is managing the workflow. Okay, workflow, like which work need to be a process part, which work is dependent on other works that will be replicated in the form of workflow. And in order to provide effective service, there is a GFSE, that is Generic Application Service Factory, and it is having a OGCE message services where you will get events and notifications. So these are the 5 components available in the OGCE platform. So how we are doing? So see here, it is very nicely represented here. A user is requested initially, right? Generally, a user requests a service in a particular portal. The first operation saying, this first operation is saying user is requesting a service to this particular portal. So this particular portal is called a GFSE portal, right? We discussed GFSE portal in the previous slide. It's called a generic application service portal. Okay. So once it is requested to this portal, what is portal will check? This portal will check the registry, right? This portal register the whatever request made by a user into the registry, because registry will give the complete information, just like a log files, right? You know, log files, same as the registry, right? So registry, and it is also requesting the factory service to create a new service. If the service is available, the service can be provided. But if it is a new type of service, this it will make a request. This portal will make a request to the factory to create a new service. Then what happened? This factory service create a new application service, and it is going to post that service. Whenever you are creating a new application, what you are, that application you are hosting on top of a physical machine by creating a particular virtual machine. Right? The portlet also gives information to the service host. Okay, that is the fifth step. Then after this, what they are doing? Users are fine. The service host is launched in a computational cloud or computational grid or in a local resources. So the application is hosted. Once the application is ready in the service host, it is hosted in cloud or grid, right? So once it is hosted, user can get the service, and user can access the service, or user can manage the service, or you can say the result, whatever generated in the application post, that is given to the user, right? So this is the 6-step process used in the OGCE to perform, to deploy new services and to maintain the things in the registry. So OGCE strategy is based upon the toolkit model. Here also we are using the TerraGrid. I told you about the TerraGrid. TerraGrid is same as your BOINC platform. Okay, so TerraGrid is going to provide you the resources. So OGCE is using the resources provided by this TerraGrid, right? And UltraScan, which is there for molecule design, or that is used by biophysicists or physicists or biologists or physicists or material scientists. So they are deploying the job. They are deploying their job submission in the Globus toolkit. Okay, that is called as Grid Resource Allocation Manager is there, and Grid Resource Allocation Manager is responsible to manage the jobs submitted in the UltraScan software gateway, right? Similarly, your chemistry gateway, that is Param Chem or Grid Chem, want to extend their job submission capability to improve the scientific workflows, and Xbuyer and its supporting tools can be used. For these projects, they are using the OGCE components. OGCE, one of the components is the Xbuyer, right? So this component is used by these projects in order to deploy the job solution or in order to request some job. OGC tools are focusing on the scientific applications and workforce management as well. And it is also, but it is differing the issues with respect to the data and metadata management. Okay, so data and metadata management is not handled by this OGC platform. For this, explicit things is required. And here also workflows is coming. Workflows can combine multiple services or it can define the flow of data, okay, from one unit to another unit. So registries are the services that can be used to look up other services and workflows. Here they are also using the messaging system are used for the different distributed component to communicate. So these are the various what the tools OGC tools is providing. Based upon that, several things are required. Okay, so you can see here OGC also provides a programming model. Like if you want to conduct a experiment, okay, and you want to carry out this experiment for 1 hour or a 1 day or a particular period of time, also that is possible by the help of OGC. And you can construct a workflow as per your requirement, and you can run with any scientific application in the computational grid or computational cloud by the help of this OGC by developing a particular model. And here there is another problem is that is called as the application wrapping problem. Application wrapping problem is that whenever we are deploying the application, for example, I have deployed application number 1 and I want to deploy another application number 2. So what happens, there may be a conflict between application 1 and application 2 if they are applied in the same tool, okay, or same gateway. So in order to avoid this, what happens? It also provides your factory service is providing application wrapping problem solutions. So they are using wrappers are used to protect a particular application from another application, okay, installed in the same device. Like our smartphone is having also lot of applications, right? So how you can distinguish one application from another application? For this, wrappers plays an important role. Okay. Similarly, GFSC is the Factory Services Wrap Services can be run as a standalone tools and they can register with X registry. X registry is providing the complete information, right? So everything you are providing in the services or whenever you are creating a new services, you have to write everything in the X registry. But all the types of problem, all the generic problems, let's say fault tolerance, reliability, all the problems are not well covered by this environment. Okay, for this specific things can be used or user need to explicitly mention what kind of services is required. So based upon that, domain specific solutions can be developed. Similarly, you can see the gadgets, whatever we are using or whatever the handheld devices are using. Suppose nowadays we are using Google gadget, that is Alexa, right, or Google Home. Okay, so these things are also used as an interface to communicate with the particular devices. Suppose I have a headphone, right, and that headphone is enabled with Bluetooth, right, and it is connected to another device. So whatever instruction I want to make, I can make that. I can give that instructions. So like just open Google. So it will open the Google and type this thing. Such type of things can be possible by the help of the gadgets, right? And these gadgets are used in the science gateways, which need to communicate with the server side component in order to execute whatever instructions you are giving via these gadgets. And these containers are using your HTTP security mechanism or secure HTTP connect between the container and gadgets. So secure connections you can establish by the help of this HTTPS protocol. Okay, so OGSC software is a open source software. It is available in the source code .net, right? You can visit this website. You can download this OGSC software and explore the things. And this is a very big project. You can create a small project or you can say sub project inside this OGS, OGCE, right? One sub project may be dedicated to one particular domain, or with respect to the end user requirement, you can develop various sub projects inside this OGCE software.